Keeping honeybees represents one of the most wonderful relationships that has evolved between two living things, a relationship that extends back to the earliest civilizations. You may have a beekeeper in your community, someone keeping bees for the production of honey. Honeybees also produce beeswax and propolis, but the significant benefit they bring is pollination, the transfer of pollen from flower to flower, a process essential to fertilization and the creation of seeds. Watching honeybees move among the flowers, collecting nectar and carrying pollen from anther to stigma has to be one of the most inspiring events we can witness, an essential process in the web of life. Without pollinating insects, we would experience a catastrophic loss of plant species. And as you know, we are facing a serious decline in pollinator populations. This pollinator is Apis mellifera, the common honeybee. This agreeable little insect has been called the charismatic representative of all bee species. She has been associated with human beings from the earliest times, traveling with our ancestors as they populated the globe. Bees were kept for the two main products they produced, honey and beeswax. Honey was a valued product. In many communities, it was the only sweetener available. Beeswax was largely used to create candles. The characteristics of beeswax make it perfect for candles, often the only source of light in some communities. These candles burn slowly with a lovely fragrance. The early beekeepers kept their bees in hives constructed from wood logs, clay, or woven straw. These simple hives are still in use in many parts of the world. But a problem with these types of beehives is that the beekeepers needed to damage the comb, even kill the bees, to access the honey. This is natural comb, pure beeswax. The bees secrete the wax from glands located between their body segments. Workers collect and chew these small flakes of wax, assembling them into the six-sided cells you see here. This natural comb is constructed in sheets hanging from the top of whatever the colony is housed in. These delicate wax structures are easily damaged. Early beekeeping practices forced the bees to regularly rebuild the comb. The major breakthrough in hive design occurred with the development of the movable frame hive. In the 19th century, there were a number of beekeepers working on movable frame hive design, but arguably the best design was created by the American beekeeper Langstroth. The beehive he patented in 1852 is still in use today. My bees are housed in standard Langstroth hives. This is a movable frame. Bees construct the wax comb inside the frames. When honey is extracted from a frame of comb like this, the comb can be returned to the hive to be refilled with honey. The bees do not have to rebuild it. The frames and boxes that hold them come in 3 different sizes. This is a large or standard frame. If you decide to start keeping bees, you'll need a beehive. Frames, brood chamber, supers, bottom board, cover, and other equipment. One of the pleasures of beekeeping is creating and assembling equipment. If you're familiar with power tools, you can make your own hive parts. Dimensions for Langstroth equipment can be found online. These commercial frame parts are manufactured from white pine. They fit together with precision. Constructing a beehive is one of the pleasures of beekeeping. With frames completed, the next step is to install foundation. These beeswax sheets are embossed with the hexagonal shapes of cells. Using their own wax, the bees will build the cells on the foundation, ensuring they build inside the frame. There are different styles of foundation. Some is pure beeswax, some has wire embedded to increase strength, and some foundation is manufactured with a plastic core. I have used all three types with success. This is a frame 10 days after placing it on a beehive. You will see the bees have constructed cells on the foundation. Many of the cells are filled with ripening honey. Constructing the boxes is straightforward. The boxes that hold the frames are called brood chambers or supers. Brood chambers contain developing bees, eggs, larvae, and pupa. Supers are used for honey storage. You will also need to construct a baseboard, inner cover, and outer cover. There is a debate about the best color to paint your equipment. I prefer the traditional white. Once your hive is constructed, you will need some bees. You can buy a small established colony called a nuke, short for nucleus. Here's one way to start a colony of bees. This is a nucleus. It contains 4 frames with some brood, adult bees, honey, and a laying queen. Once you have your nuke, it is time to suit up and transfer the frames and bees to your new hive. Be certain the queen is on one of the frames you transfer over. A month later, your colony may look like this. This bottom wooden box is the brood chamber. The queen is confined to this box. The colony has one queen. She lays eggs in the cells. You can see the eggs in the bottoms of these cells. The life cycle of a honeybee is complete metamorphosis. The eggs hatch into a larva. The larva is fed by nurse bees, increasing in size until it almost fills the cell. At this point, workers cap the cell and the developing bee enters the pupa stage. The brown caps on these cells cover developing pupa. 21 days after the egg was laid, an adult bee emerges. The queen lays both female and male eggs. The male or drone eggs are laid in larger cells. These are drone cells. The activity in and around a beehive is fascinating. Watch the entrance of your colony and you will notice that some of the returning field bees have filled their pollen baskets with pollen. Pollen contains essential nutrients for the developing larva. The pollen is stored in cells. The different colors we see here tell us the bees have been sourcing pollen from a wide variety of plants. This field bee is searching for a cell to pack her pollen into. Finding one, she scrapes the pollen into the bottom of the cell. Honey is also stored in cells. The frames designated to hold honey are placed in a super above the brood chamber. The upper box is a honey super. As the colony population increases, field bees will start to fill this super with honey. Let's look inside. Again, I'm using smoke to control the bee's alarm response. The smoke obscures any alarm pheromone that a guard bee may emit. I have also protected my face with a veil. This is a good idea no matter how experienced you are. A sting close to your eye is very unpleasant. I would also recommend gloves. It is often difficult to manipulate colonies without pinching bees with your fingers. This metal mesh is a queen excluder. This is how the queen is confined to the brood chamber. She is too large to pass through this barrier. The spacing is such that workers can pass through, but the queen can't. Looking down on the brood chamber, we can see it holds 10 frames. This is standard and comes from Langstroth's original hive design. He used the fact that the bees construct natural comb with a precise spacing. His design mimics natural spacing, creating what he called the proper bee space. I used 9 frames in the honey supers. The resulting deeper cells are easier to uncap when extracting honey. By midsummer, you should have some honey to extract. Honey is produced from nectar. Honey bees collect nectar from flowers, then transform it to honey through a process of regurgitation and evaporation. This process modifies the sugars and reduces the water content. When the honey is fully processed and the water content is reduced to the point that the honey won't ferment, the honey is capped. In this image, this is uncapped honey, and this is capped honey. Ideally, 75% of a honey frame will be capped before you extract the honey from it. First step in harvesting your honey crop is to remove the bees from the honey supers. There are a number of ways to do this. When we kept honeybees commercially, I used a gas-powered blower to literally blow the bees out of the supers. A more civilized way, if you only have a few colonies, is to use a bee escape. This device is placed under the honey super. The red tapered cones provide an exit for the bees from the honey super to the colony below. They do not return through the cones back to the honey super. After a couple of days, the super is free of bees and you can lift it off. There are a number of different designs of bee escapes. Most of them are effective. Not all beekeepers can use this method. Apparently in areas where the small hive beetle is a problem, the beetles quickly occupy and damage the unprotected honey super. This is the first crop from my bees this year. The honey supers on my truck represent about 100 kilograms of honey. This is the output from 4 colonies in midsummer. If you are interested in keeping bees, find a beekeeper willing to let you accompany them while they work with their bees. Or you may find beekeeping courses offered in your community. You don't want to attempt this without some training. There is a lot to know. If you live in an area with severe winters, you will need to protect your colonies from extreme weather and ensure that they have ample honey to survive for 6 months. Honeybees are vulnerable to a number of diseases and pests. This mite, Varroa jacobsoni, is a very significant problem. And in our community, we also have a very large pest to deal with, Ursus americanus. You may have noticed my bees were housed in a steel fence cage with an electric fencer. So far this has been effective. This small colony was temporarily outside the housing. It wasn't long until a black bear visited. There is also growing evidence that a new category of an industrial pesticide is seriously affecting all pollinators. The European community has suspended the use of these neonicotinoids until the full effect of this new systemic pesticide is known. If you're interested in learning more about honeybees, view our video, Honeybees Life Cycle. We will soon be releasing a video demonstrating honey extraction. For more science and technology videos and projects, visit our website, hylaroad.com.